Imagine you're standing on a tall building, looking down at the street below. You drop a marble. It falls. You drop a bowling ball. It falls at exactly the same speed. Not faster, not slower. Exactly the same. Now here's the crazy part. This exact same phenomenon happens on the moon. If you drop that marble and bowling ball on the moon, with no air resistance, they'd hit the lunar surface at the exact same instant. Even though the moon is 238,900 miles away. This isn't magic. This isn't coincidence. This is one of the most powerful ideas humanity has ever discovered. A law of physics. And today, we're going to unpack what that actually means. Welcome to What Is? And today we're answering the question, what is a law of physics? So what is a law of physics? Before we dive in, let's get one thing straight. When physicists talk about laws, they don't mean rules that someone invented and enforcing upon the universe. These aren't like speed limits or no smoking ordinances. These are discoveries. Observations about how the universe actually behaves consistently, everywhere, all the time. Think about that for a second. Every time you throw a ball, every time light bends through a window, every time your phone's accelerometer detects motion, something like 40 different physical laws are quietly doing their jobs. But here's where it gets really interesting. These laws aren't just true, they're predictive. They allow us to build machines that fly, predict where planets will be decades from now, and, perhaps most impressively, understand things we've never actually seen. Let's start from the beginning. Defining the concept. A law of physics is essentially a concise mathematical or verbal description of how the universe behaves under specific conditions. It describes a relationship that holds true every single time, everywhere in the observable universe. Sounds simple, right? Well, buckle up, because the simplicity is deceptive. The key word here is every single time. That's what makes a law different from a theory or a hypothesis. A hypothesis is an educated guess. A theory is a well-substantiated explanation. But a law? Oh, a law is something different. Here's a helpful analogy. Think of laws of physics like the rules of a game. Except the game is reality, and the rules were never written by anyone. They were discovered. When Newton watched that apple fall, he didn't create gravity. He discovered that there's a relationship between mass, distance, and the force pulling objects together. The relationship was always there. Newton just had the brilliance to see the pattern. That's what physics laws do. They identify patterns so fundamental that they govern everything from the smallest subatomic particles to the largest galaxies. The big players. Let me introduce you to some of the most famous laws of physics. These are the rock stars of the physics world. Names you've probably heard, even if you don't remember what they actually describe. Newton's 3 laws of motion. These are the foundation of classical physics. First law, an object at rest stays at rest, and an object in motion stays in motion unless acted upon by an external force. This is sometimes called the law of inertia. Second law, force equals mass times acceleration, or F equals ma. This is the equation that lets engineers calculate exactly how much thrust a rocket needs to launch. Third law, for every action, there is an equal and opposite reaction. This is why you feel recoil when firing a gun. The bullet goes forward, the gun pushes back with the same force. It's also how rockets work. Exhaust goes one way, the rocket goes the other. The law of universal gravitation. This is Newton's big one. Every object in the universe attracts every other object with a force that depends on their masses and the distance between them. That apple that fell on Newton's head? It was attracted to the Earth. But here's the mind-blowing part. The apple was also attracting the Earth. The force is just so tiny when one object is an apple, and the other is an entire planet, that we don't notice the Earth's movement. Conservation laws. These are absolutely crucial. The laws of conservation of energy, momentum, and mass state that certain quantities cannot be created or destroyed. They can only be transferred or transformed. Energy conservation is particularly wild. It means the energy in your body right now is the same energy that's been circulating through the universe since the Big Bang. You're literally carrying around 13.8 billion years of stored starlight in your cells. Thermodynamics. These laws describe heat, energy, and work. The first law is essentially conservation of energy applied to thermal systems. The second law, which is where things get fascinating, states that entropy always increases in an isolated system. Entropy is a measure of disorder or randomness. This law explains why time appears to flow in one direction, why you can't unscramble an egg, and why perpetual motion machines are impossible. Einstein's laws. Albert Einstein gave us two especially important ones. The theory of special relativity gave us the famous E equals mc squared, showing that mass and energy are interchangeable. It also told us that nothing can travel faster than light, a speed limit built into the very structure of space-time. General relativity redefined gravity entirely, showing that massive objects don't just attract other objects, they actually bend the fabric of space-time itself. What we perceive as gravity is actually objects following curved paths through warped space. If you're finding this fascinating, you're not alone. But here's the thing, channels like this one exist because of people like you. If you're enjoying this video, hit that subscribe button. Join the What Is community, because there's a whole universe of questions left to answer. We explore science questions like these every Monday, and other topics every day of the week. Don't miss out. Now let's get back to the physics, how laws are created. Now here's where people often get confused. How do we know these laws are real? Who decides what's a law and what's just a good guess? Great questions. The process is beautifully rigorous. It starts with observation. Someone notices something interesting. Maybe it's a pattern in how planets move, or how light behaves when passing through water. Then comes the hypothesis. A scientist proposes a possible explanation, usually in the form of a mathematical relationship. Here's the critical part. The hypothesis gets tested. A lot. Different scientists, in different places, with different equipment, all trying to find a flaw in the idea. If the hypothesis survives enough rigorous testing, if it consistently and accurately predicts outcomes, it earns the prestigious title of law. But here's the catch that many people don't realize. No law is considered absolutely permanent. Scientific laws are always provisional. They're the best explanation we have, given our current understanding and technology. Case in point, Newton's laws are incredibly accurate for everyday situations, dropping balls, driving cars, launching satellites. But when you get to extremely high speeds approaching the speed of light, Newton's laws break down. Einstein's relativity takes over. And when you get to the quantum scale, the world of atoms and subatomic particles, even relativity isn't enough. We need quantum mechanics. Does this mean Newton's laws are wrong? Not really. They're right for the situations they describe. They're wrong only in the sense that they don't tell the complete story. They're like a map that's perfect for driving across a city, but useless for navigating on the moon. Physics is cumulative. New laws don't usually overthrow old laws. They extend them, or show where their domain of validity ends. This is actually one of the most beautiful aspects of physics. Each generation stands on the shoulders of the previous one, building more comprehensive understanding. Misconceptions. Let me address some common misconceptions about physics laws, because these can really trip people up. Misconception 1. It's just a theory. People often use theory loosely, meaning just a guess. But in science, a theory is as solid as it gets. A law and a theory are different things, not levels of certainty, but different types of descriptions. Laws describe what happens. Theories explain why it happens. Evolution is a theory. Gravity is a theory, both Newtonian and Einsteinian. That doesn't mean scientists are just guessing. It means these are extremely well substantiated explanatory frameworks. Misconception 2. Laws are absolute. As we just discussed, no. Laws describe relationships that hold under specific conditions. When conditions change significantly, very high speeds, very small scales, very strong gravitational fields, our laws may need revision or replacement. Misconception. 3. Physics laws are invented. This is a philosophical debate, but the prevailing view among physicists is that laws are discovered, not invented. The universe behaves in certain ways. Our job is to figure out those ways. Math is the language we use to describe them, not the rules themselves. Misconception. 4. Laws of physics are opinions. Some people try to dismiss scientific findings by calling them just opinions. But physics laws aren't opinions. They're rigorously tested descriptions of observable reality. If you think they're wrong, go ahead. Build better equipment, run better experiments, and publish your findings. That's exactly how science is supposed to work. Why this matters. Here's why all of this matters so much. Physics laws are the foundation of everything. Every piece of technology you've ever used, every building that stood up, every medical imaging scan, every satellite in orbit, all of it exists because we understand these laws well enough to work with them. But there's something deeper too. These laws connect us to the universe in a profound way. When you understand that you're made of atoms that formed in stellar cores and scattered across the galaxy, that understanding comes from physics. When you know that the light from distant galaxies left its source millions of years ago, that knowledge comes from physics. There's something almost spiritual about it, not in a religious sense, but in the sense of feeling connected to something vast and ancient and structured. These laws are humanity's greatest achievements. They're abstract descriptions that let us predict and control the physical world in ways that would seem like magic to anyone from just a few hundred years ago. The limits of knowledge. So we've established what physics laws are and how powerful they can be. But let's be honest about the limitations too. We don't have all the answers. There are still fundamental questions that physics hasn't solved. What is dark matter? We can't see it, but we can observe its gravitational effects on galaxies. Something is out there, making up about 27% of the universe. We have no idea what it actually is. What is dark energy? This is even stranger. The universe is expanding at an accelerating rate, and some form of energy filling all of space is driving that expansion. We call it dark energy, but that's really just a name for we have no idea what this is. The measurement problem in quantum mechanics is deeply puzzling. At the quantum level, particles don't have definite positions until they're observed. This is deeply weird, and physicists still debate what it means. These aren't failures, they're frontiers. They're the boundaries of human knowledge, where new laws might be discovered in your lifetime. That's genuinely exciting. Every major law of physics was discovered because someone looked at the unknown and said, I want to understand this. Philosophical implications. Now let's get a little philosophical. Don't worry, we'll keep it accessible. The existence of consistent physical laws raises some fascinating questions. Why is the universe orderly rather than chaotic? Why can we discover these laws at all? Why is the universe comprehensible? Some physicists are what we call Platonists. They believe these laws exist independent of the universe, as abstract mathematical truths that the universe happens to follow. Others take a more pragmatic view. The laws are useful descriptions that work, and that's all we need to know. Either way, the fact that we can discover these laws, that our brains evolved on the African savanna to hunt and gather, can somehow comprehend the fundamental nature of reality, that's pretty remarkable. Some people find this frightening or dispiriting, that we're just governed by physical laws. But I think it's beautiful. There's something wonderful about being a collection of atoms that's evolved to the point where it can understand the very forces that created it. We are the universe understanding itself. How cool is that? Before we wrap up with our bonus fact, I want to ask you something directly. What questions do you have about physics? What concepts have always confused you? What have you heard about but never fully understood? Drop your questions in the comments below. This channel exists to answer your questions, so let's hear what you want to know. If you want more content like this, Detailed explanations, fascinating facts, and the occasional deep dive into the mysteries of the universe. Make sure you're subscribed. Hit the bell icon too, so you never miss a new video. Now let's end with something special. Bonus fact. Here's your bonus fact for today. The most precise physical law ever measured is something called the electron magnetic moment. Scientists have calculated this value to an accuracy of about 1 part in a trillion. That's like measuring the distance between New York and Los Angeles to within the width of a human hair. This level of precision was achieved over decades of careful experimentation, and it represents one of the most accurate agreements between theory and experiment in all of science. But here's what's really interesting. This extreme precision almost didn't happen. The original calculations suggested there might be a slight discrepancy from theoretical predictions. This anomaly prompted decades of additional research, improved experimental techniques, and eventually led to even more precise confirmations of our best theories. Sometimes what looks like a problem turns out to be an opportunity for deeper understanding. That's the spirit of physics. That's the spirit of science. So there you have it. A law of physics is a concise description of how the universe behaves, a relationship that holds true everywhere, every time, under specific conditions. These laws aren't rules imposed on reality. They're discoveries about the fundamental nature of existence. They connect us to the cosmos in profound ways, and they make modern civilization possible. Thanks for watching What Is. I'll see you in the next one.